So welcome to the next lesson of Stage 2 General Mathematics. We'll be going through Chapter 8b, which is on home loans in this little mini lecture. So typically, for a home loan, we find that they're much larger than the personal loans that we've talked about in the previous section, which was 8a. So typically a mortgage or a home loan, which is what they're otherwise known at, we can find between $100,000 and sometimes anything up to about $3 million. Now, where we are in Whyalla at the moment, you can pick houses up in the order of $60,000 to $100,000. And if you wanted to live in some of the really nice top-end suburbs in Sydney, it could be anything upwards of $3 to even $4 million if you wanted to head down that path. Also, we find that the terms of the loan are much longer. We note here that most Australian mortgages are in the order of 30 years. So typically about 10 years ago, typical mortgages about 25 years. But as we saw in one of the examples I did in question 8a, we find that if we extend the period of the loan or the term of the loan, the repayments decrease and therefore become more affordable on a weekly to weekly basis for the average Joe citizen. We also note here that the interest rates can be fixed or they can be variable. So a variable rate means that the bank will charge us a different varying interest rate from month to month to month, perhaps, if they change. It can be that frequently. The bank might decide to set the interest rate that they're going to pay, so they're going to charge you on a mortgage for 3 months. And then for some reason they might increase it 0.5% or decrease it 0.1% perhaps. So interest rates can be fixed. Now this can be fixed for the life of the loan, for the entire term. The loan, in this case, would be maybe looking at 30 years, or it can be fixed for 5 years or for 10 years. We also have variable loans. Now a variable loan will vary in its interest rate, can be from month to month. In Australia, the interest rates, or the variable interest rate, is typically set by the Australian Reserve Bank, which will meet on from memory, it's the first Tuesday or the last Tuesday of the month. And from that Reserve Bank meeting, the governors of the Reserve Bank will decide whether they raise or decrease federal interest rates, in which case the bank usually follows on with that. So they might be changed from month to month, they might be steady for 6 months, sometimes even 12 months, or they might decrease from month to month, or every 3 months perhaps. But it's variable and that rate will fluctuate very greatly over time. Also, for mortgages in Australia, we have the option of an interest-only loan, where interest-only is you only pay off the interest amount that's due per month for that loan. Now, this is typically used by property investors who only want to service the interest of the loan from their rental income from month to month. Okay. Typically, an interest-only loan isn't used as your principal place of residence or for a property that you would live in. Let's take a look at a question. So in this question, we have question 2. Shane and Julie have taken out a $250,000 loan to purchase an apartment. They'll repay that loan over 20 years at 6.25% per annum, fixed interest, compounded monthly. So we need to calculate the monthly repayment. So as I've just gone and underlined it, this is all that critical information that we'll need to feed into TVM calculator. Alright, so the number of this compounding periods per year is 12 because we're going monthly. The payments per year is 12. The future value is 0. The present value is over here. We're going to be given $250,000. So that's a positive. The interest rate is 6.25%. And N, which is the number of periods, it's a 20-year loan and 12 periods per year. So 20 times by 12 is 240. And the payment is the figure that we want to find. Answer. So monthly repayments are minus $1,827 and 32 cents. Alright. So this is our answer. 32. Calculate the total interest charged. So, remember, interest equals total payment minus the present value, which is equal to 240 times by 1827.32 minus 250 with 3 zeros behind it. So if we plug these values into our calculator, we should end up with $188,000, $88,556.80. And there's our answer. Okay, so now we're going to continue our quest through chapter 8b on home loans. This time we're going to consider what's called a mortgage. So the question that's posed is, Stefan has purchased a house valued at $420,000. He has saved a deposit of $40,000, but he must borrow the remainder. First question, part A, is how much money must Stefan borrow? So we say borrow amount equals the value of the house minus deposit equals 420,000 minus 40,000, which is equal to $380,000, which is perfectly correct. Now, just as an aside, as is required by current borrowing regulations in Australia, unless you have more than a 20% deposit for your mortgage that you want to arrange with a bank, you have to pay what's called mortgage insurance. Now, this is an additional sum that you would pay to the bank so that the bank can take out an insurance policy in case you, as the borrower, for whatever reason, happen to default on your loan. The bank can still get their money back. So that would be, just be aware that this sum of $40,000 is less than 10%, the $420,000. So in this case, Stefan would have to take out an additional sum or pay for mortgage insurance from somewhere. So that, as is 10%, would have to be $42,000. But we shall continue. Alright, so next, Stefan agrees to repay the loan over 30 years. Okay, at 5.7% per annum, fixed interest, compounded quarterly. We need to find Stefan's quarterly repayments. To this, once again, we turn to our old friend TBM calculator. So, the compounding periods per year, we're told it's compounded quarterly. So this would be 4, as is the payments per year, or payment frequency. The future value is, in this instance, 0, because the bank is we're going to be paying the money back to the bank over time. The present value, we want to find the payments. The present value is the bank is going to give us $420,000. The interest rate, as is stated here, is 5.7%. And the number of years, we're told it's 30 years at 4 compounding periods per year. So the number of compounding periods we have, 3 fours are 120. All right. So from here, turn on our calculator. If we go apps, finance, TBM solver, plug our numbers in, so 120, 5.7, going down the page, 420, 1, 2, 3, solve for that. Our future value is 0, we leave that as it is. 4 and 4. Go back to our payment value, hit alpha and enter, which is the solve button. And our quarterly repayments, minus $7,326, and let's say 17 cents. So in here, we put $7,326 and 17 cents. Now, from here, we know that this sum here has got to be negative because we're going to be giving money away back to the bank, or giving money back to the bank. The bank has given us money, so we're taking a positive, we're gaining something at the start, and over the period of the loan, we need to repay that money back to the bank. Alright. Part B, part 2, asks us to show that the total interest that Stefan will pay is more than the amount of the original he borrows. Okay, so remember, our interest equals the total of the repayments minus the present value. In this instance, it's 7,326.17 times by 30 times by 4 minus 420 to 3. And if we plug that into our calculator, we end up with the total interest we pay. This is the interest only component, remember, the interest repayment. 140 and 40. So as we can see, this number here, $459,140 and 40 cents, is greater than the initial loan amount, which is $380,000, which means we have to pay the bank in the order of $79,000 more than the initial value of the loan. That's how a mortgage operates. We're asked in 6A to find the monthly repayment Madeline needs to make with this starting interest rate. So, we go over here. Our compounding periods per year is, we're told, we are compounded monthly, so this will be 12. Our payments per year will also be 12. The final value of the loan will be 0. We'll need to find the payment value. The present value is what we're borrowing, which is $370,000. The interest rate that we're told is 5.75. Our number of periods is 20 years times by 12, which is 240. So if we turn our calculator on and we go into Apps, Finance, TDM Solver, plug these values in, we'll find out that this, the repayments, this will come out as negative 2597.71. So that's negative, meaning we have to pay back the bank the money. So here we have 2597.71. There's our answer. Now, part B asks us to calculate our outstanding debt after 5 years of repayments. Okay, so when we plug all these values in, so the new term, the remaining period is 180, the interest rate is 6%, present value is 312,822.43, solve for the payment, the future value being 0, so there's nothing left, and our compounding and payment periods per year is 12. If we plug all that information in and solve using TDM Solver, we solve for the payment, we should end up with minus 2638 and 93 cents. So as you can see from here, our payments have gone up about, about $45 a month due to our 0.25% increase. So Madeline's new monthly repayment is 2638.93. There we go. So C part 2, we're asked to find the total interest charged over 20 years of the loan, assuming the rate stays constant at 6% per annum for the next 20 years. So in order for us to do that, we need to remember that the total interest equals the total repayments minus the principal that we first started with. So to calculate that, let's look at the second set of terms first. So it's 180 times by 2638.93 plus we had 60 times by 2597.71 minus 370.123. Okay. Now if we plug that into the calculator, we'll end up with 180 times by 2638.93 close bracket plus open bracket 60 times by 2597.71 close bracket minus 370.123, enter. So as we can see from our trusty calculator, we end up with a total interest paid of $260,870.00. Now, despite what's written in the Hazy and Hazy textbook, I've double checked my answers and double checked my methodology against the answers are in the back of the textbook for this particular question. I can guarantee you that these are in fact correct. Alright, thank you.